Today's lesson is about the Pythagorean theorem. The Pythagorean theorem is one of the most important topics when you learn basic trigonometry, which is what Chapter 8 is about. On your notes, find the box labeled Pythagorean theorem and add the following information. So the Pythagorean theorem says that if it is a right triangle, then this equation holds true. A squared plus b squared equals c squared. Now, the c in that equation is always going to be the hypotenuse of your right triangle. Hypotenuse, remember, that just means the longest side of your right triangle. The a and b in your equation are the lengths of the two leg sides. It doesn't really matter which leg side you label a and which leg side you label b. The important thing is that they're not the hypotenuse. So the square of each leg side added up equals the hypotenuse squared. I want you to notice that this is only true for right triangles. That's going to be key later on. It doesn't work for all triangles, just right triangles. Now, occasionally you're looking at a drawing and you're trying to identify which side is C, which side is the longest. And in this picture, it's pretty clear that this side is the longest side, the hypotenuse side. But sometimes you look at a picture and you can't quite tell which side is the hypotenuse side. When that happens, here's a tip. The right angle symbol always points to the hypotenuse side. Draw a little arrow there to remind yourself that the hypotenuse is always opposite the right angle. So let's practice identifying where C is in a diagram. And question 1, which side is C? If you said X, well done. Now, the other two sides can be A and B. The leg sides, it doesn't really matter which one you label A and which one you label B, because when you plug it in, you're just squaring and then adding them anyway. So you could have B squared, then A squared, and it should still work out. So let's replace A with 12, B with 9, and C with X. Now our Pythagorean theorem equation looks like this. Now, you remember PEMDAS, order of operations? You have to do exponents before you do adding. So let's do all the squaring. 12 squared is 144, and 9 squared is 81. Add those like terms. And now to solve for x, you have to get x by itself. You're going to have to cancel out the square, the exponent 2 on the x. To cancel something out, you know how you do the opposite? To cancel out times, you do division. To cancel out plus, you do subtraction. Well, to cancel out a square, you do its opposite, square rooting. So square rooting both sides gets x by itself. X equals 15 when you square root 225. Go ahead and try question 2. X is on the longest side, so that's your C. The other two sides can be your A and B leg sides. When you plug everything in, it should look like this. Then you do the squaring and add your like terms. To get x by itself, use square rooted. You should get x equals 17. Question 3. Which side is your C? If you said 10, well done. That's your hypotenuse side, your longest side. You can see how the right angle points to it. So when you plug things in, this time, x is one of the leg sides. So your equation might look like this. After you do the squaring, you need to get x squared by itself, so you subtract 16 from both sides. Now that x squared is by itself, now you can square root both sides of your equation to cancel out the square. Now this time when you try to square root 84, if you put it in a calculator, it gets you a run-on decimal, so you're going to want to factor tree and simplify the square root. When you simplify the square root, you should get 2 square root of 21. For question 4, this time your hypotenuse, is 16, and 10 and x are your leg sides. As you simplify your equation and get x squared by itself, you should get x squared equals 156. Then when you square root both sides, you should get x equals 2 times square root of 39. Question 5. When you have a word problem, it's a good idea to first identify all the key information like numbers in the question as well as what they are asking you to figure out. So if you identify the numbers and either circle or box or underline the question phrase, they're asking how high in the house does the ladder reach, that might help you figure out how to draw the diagram they're describing. So there's a 12-foot long ladder leaning against the side of a house. So if the ladder is the leaning side, that would end up being on the hypotenuse. The base of the ladder is 4 feet away from the house. And then they're asking how high on the house does the ladder reach. So that's what they're asking for. So that's what you label x, the height of the triangle. So when you use Pythagorean theorem, your leg sides, your a and b sides, are x and 4, and your hypotenuse is 12. Just like the previous problems, you can solve for x. However, notice something unusual. They're asking you to write your answer to the nearest tenth of a foot because as a word problem, this is representing a real-life situation where you don't really want to have to try to measure 8 square root of 2 in feet. You want actual number of feet. So if you type 8 square root of 2 in your calculator, round to the tenths place. You should get around 11.3 feet. Don't forget your units like I did. Make sure you have feet. Now the Pythagorean theorem also has a converse. The converse, same thing but backwards, says that if the equation a squared plus b squared equals c squared is true for your triangle, then it must be a right triangle. Let me show you what that really means. If I have these 3 sides of a triangle, the longest side would be the c. 5 is bigger than the other side, so 5 is the longest side. If I plug that in, and if I plug 4 and 3 for the leg sides in Pythagorean theorem, let's see what happens. If I square each piece and simplify, it turns out it's a true equation. The left side equals the right side. Because 4 squared plus 3 squared equals 5 squared turned out to be true, I can assume the triangle was a right triangle. That's the conclusion in a different color. Add a right angle symbol. Next, use the converse of the Pythagorean theorem to solve question number 6. First off, out of the 3 side lengths of this described triangle, which one would have to be C? If you said 32.5, well done. Now, the other 2 sides can be your A and B. Go ahead and make your Pythagorean theorem equation, and we're going to check to see if it works out or not. If you square each piece and add like terms, you do get a true equation. So if you said yes, it's a right triangle, well done. The next theorem, Theorem 8-3, helps you figure out information about the triangle when a squared plus b squared does not equal c squared. For example, if the c squared half of the equation is greater than the a squared plus b squared half of the equation, then you know your triangle has to be obtuse. The way I remember this rule is if I picture an obtuse triangle like this one, and any obtuse triangle with an obtuse angle, you're going to have opposite the obtuse corner one especially long side. So the C is an especially long side. It's so much longer than the two a and b sides that when you square it, it's greater than the square of the a and b sides combined. Contrast this with the next theorem. If c squared is less than a squared plus b squared, that tells you that it must be an acute triangle. This is true because in any acute triangle where all three corners are narrow and acute, then even the longest side is really only barely longer than the two shorter sides. In other words, c squared is in no way going to be greater than the combo of the square of the shorter side. C squared is less than a squared plus b squared because c is not really impressively much longer than the other two anyway. Now, to use these theorems to identify what type of triangle you have based on the side lengths, here's how I set it up. Make a note to yourself. Start with c squared, then draw a circle to represent the space where later you're going to put an equal sign or an inequality sign of some kind, and then b squared plus a squared on the other side. So looking at 7, what would have to be the c? It would have to be 12 because that's the biggest number, so that would be the longest side. So if we put that first in c squared versus a squared plus b squared and simplify each side, 12 squared is 144, 4 squared plus 9 squared is 97. If you figure out what inequality should go in the circle, 144 is greater than 97, so we write a greater than symbol. And if you look at the theorems above, if it's c squared greater than a squared plus b squared, it has to be obtuse. Try question 8. C would have to be 7. Plug it into your expression and simplify. 49 is greater than 34. If it's a greater than symbol, if it's c squared greater than the other side of the equation, then it's an obtuse triangle. Try question 9. C is 11. If you get c squared is less than the a squared plus b squared side of the equation, that tells you it's an acute triangle. 10 is a bit of a challenge question. See how much of it you could figure out. Here's a quick tip to get started. Type square root of 5 in your calculator to figure out what length that actually represents. A little bit over 2. A common mistake people make is they assume that square root of 5 is the longest side, the c side, but actually if you square root 5, it actually turns out to be the shortest side out of the 3. So that means this time your c is 5. If you plug it all in, it should look like this. Now watch this closely. See how we have square root of 5 squared? Because square roots and squares are opposites, they cross out. We used that trick earlier, but before it was square rooting to cancel out a square. Now it's a square canceling out a square root. It works either way. Those opposite functions cancel out, leaving just 5 there. Now, because 25 is greater than 21, what type of triangle would it be? Obtuse.